Sorry guys, I'm not super sophisticated with editing clips, so it cut off here. And so I'm just starting a new video. Alright, so we're going to look at some equation writing. We're going to start with Tom and Jack. Draw a little picture to represent Tom and Jack's amount of marbles. Tom has twice as many as Jack. Okay, so if this is Jack's amount of marbles, then this would be Tom's. Twice that. There's Jack. So Tom would have the amount Jack has times 2. So I see 3 J's. It says together they have 78 marbles. So from here to here, that value is 78. So what would our equation be? Well, this one right here represents Tom. The amount that he has is twice Jack's. But notice how there's the amount that Jack has is shown 3 times. We can use J as a variable to represent the amount of marbles that Jack has. 3 times J is equivalent to 78. See how a bar model can help you? Alright, so then Mrs. Kingley's class right here. Mrs. Kingley's class has 25 boxes of candy. $25 boxes of candy. We'll label this Lee class candy. It says each box of candy has the same number of pieces in it. Notice how I'm kind of going one part at a time. I'm not reading the whole thing at once. It can be overwhelming to do it all at once. So each box of the 25 has the same number. So let's say this is one box. We don't know how much it has, so we can put C for candy. But we know it's equal all the way for the whole class, for all 25. Then it says that the total number of pieces that she has is 450. So in looking at this image here, I see that there's 25 boxes, and that each box has C amount of candy. I'm going to write this somewhere else because it's hard to see. Maybe right here. 25 times C is equivalent to 450. There we go. Again, in 5th grade, you don't have to solve. That is 6th grade. Okay, so Friday, we're adding decimals here. So 13 and 21/100ths plus 5/10. When we add decimals, we want to line them up by their place value. We can put a 0 here. 50 hundredths is the same as 5/10. Okay, so 1/100th plus 0/100ths is 1. 2/10ths plus 5/10ths is 7/10ths. And then 13 plus 0 is 13. 13 and 71/100ths. Okay, so I'm going to erase this and make space for 15. 49 and 27/100ths times 87/100ths. Okay, so when we're multiplying decimals, remember it's a little easier. First of all, you don't need to line them up by their place value. And it's a little easier to pretend like there aren't decimals there. So we can come back to that at the end. Instead, let's estimate. That'll help us know where to put the decimal point. So 49 and 27/100ths, that 2/10ths makes the 9 stay the same. It's about 49. Now 87/100ths at 8/10ths makes the 0 round up to 1. So our answer should be close to 49. Okay, so now we can go ahead and multiply and pretend like this is 4,927 times 87. We'll worry about the decimal points at the end. Okay, 7 times 7 is 49. We're going to carry that 40 to the tens place. We're pretending like it's the tens place. 7 times 2 is 14 plus 4 is 18. Now remember, it really would have been 7 times 20 equals 140, 148. Oh, 180, I mean. So that's why we're putting the 1 on top of the hundreds place, yada, yada, yada. 7 times 9 is 63, plus the 1 is 64. 7 times 4 is 28, plus the 6 makes, 34. I'm doing this in my head. 28. Okay, so now I'm going to the pretend tens place. That's really 8 tens. That's why we're supposed to put a 0 here in the next row. Okay, so 8 times 7 is 56. It's really 80 times 7. That's why it ends up being 560. Okay, moving on. 8 times 2 is 16, plus the 5 is 21. 8 times 9, 72. 8 times 4 is 32, plus the 7 makes 39. Okay, so the hard part now is figuring out where to put the decimal point. So again, we want our answer to be somewhat close to 49. Okay. So where should we put the decimal point so that it's equivalent to, or it's close to 49? If we were to put the decimal point, let's see, here, what? Here. Okay. Trying to make the decimal point easier for you to actually see. That would be 428,649. Nowhere close to 49. If we were to put it here, it would be 42,864 and 9/10. Nowhere close. You can probably figure out that if we put the decimal point here, 42 and 8,649 10,000ths, that's a lot closer to 49. So our estimate helped us figure out where to put the decimal point. Now you might remember that we did learn a trick this year, and tricks can help you check your work. Look at the two factors and see how many digits are to the right of the decimal point. 2 digits, 2 digits. That makes a total of 4 digits that should be to the right of the decimal point in the product. And they're right here. Awesome. So now I'm going to go to the next morning math minute and start with Monday. Okay, so we're subtracting fractions, so we're going to review the steps to help us remember this process. Okay, so step 1 is line the digits up, line the fractions up so they're on top of each other. 4 1/4 minus 1 1/8. Okay. Step 2 is find common denominators. So 4 1/4. Let's skip count until we find a common denominator. Okay, so 2/8 is equivalent to 1/4, and it has the same denominator as 1 1/8, so that'll work. Instead of 4 1/4, let's do 4 2/8. They are equivalent. The difference is that 1/4 is in simplest form. Okay, so now we're doing 4 2/8 minus 1 1/8. 2/8 minus 1/8 is 1/8. You subtract the numerators. 4 minus 1 is 3. 3 1/8. Now you could always check your work by adding 3 1/8 plus 1 1/8. And when you do that, you get 4 2/8. Right there. Okay, so, all right, 5 2/3 plus 2 4/5. This is going to be, oops, I didn't want to get rid of that. This is going to be a fun one. Okay, so step 1, line them up and find common denominators. Okay, so 2/3. I'm going to skip count here, the denominators. 3, 6, 9, 12, 15. The numerators 2, 4, 6, 8, 10. All right, 4/5. Let's skip count. 5, 10, 15. I'm going to stop there because look, they're the same. 4, 8, 12. So I've got 2 equivalent fractions that have the same denominator. 10/15 and 12/15. Okay, so now I can add them up. 10/15 plus 12/15 is 22/15. 5 plus 2 is 7. Okay, 7 and 22/15. So you can already see that it's not in simplest form because it's an improper fraction. 22/15. So I can subtract out a whole. (22) minus 15 is 7, so this becomes 7/15. We can't forget about the whole that we subtracted out. That makes 22/15 equivalent to 1 7/15. So let's replace 22/15 with the mixed fraction. If we put this all together, it's 8 and 7/15. Okay, Tuesday. Zooming in. All right, same thing here. We're going to be starting by lining them up and finding common denominators. Okay, so 2/3. My stylus has broken, so I'm sorry about my terrible handwriting. Okay, so I'm going to stop here because 6 1/9. I see right here that 6/9 has the same denominator. Okay, so this is 6/9 here. Okay, so we need to subtract 6 1/9 minus 4 6/9. We just can't subtract 6 from 1. So we're going to need to borrow from the 6. Okay, let me draw you a little picture, please. Allow me to do this. I'm going to show you, I'm going to represent 6 holes. Trying to make them about equal, but they're not, so sorry. Okay, and then 1/9, so I need 1/9. Okay. All right, so 1, 2, 3, 4, 5, 6 1/9. Okay? So if we borrow from the 6, we can take one of these holes and break it into ninths. That changes the way the number is written, but it doesn't change the value. Now I have 5 holes, and I actually have 10 ninths. So I took one of these holes, and I replaced it with 9 ninths, and then 9 ninths plus the 1/9 makes 10 ninths. I'm just showing you what my picture... I'm just showing you what I'm about to do with the picture so it kind of makes sense. So let's go back to 6 1/9. I'm going to take a hole from this 6 because 5 plus 9 ninths is the same as 6. And I'm not going to forget the fraction 1/9. So this becomes 5 and 10 ninths. It's the same thing as 6 1/9. The only difference is how it's written, okay? This one is written with an improper fraction. But the good news is now I can subtract and come up with my answer. So 10 ninths minus 6 ninths is 4 ninths. And then 5 minus 4 is 1. So we're left with 1 and 4 ninths. The last thing you need to check is to see if this is in simplest form. And it is, because 4 and 9 don't share any common factors. Okay. So now, let's go to 5 2/3 minus 2 4/5. Same steps. 5 2/3 minus 2 4/5. Line them up. Now you want to find common denominators, so let's skip count over here. Okay, and then 4/5. So there's my common denominator right there. I feel like I've already done this. 10/15 and 12/15. Okay, so we're faced with the same challenge again. We're faced with the challenge of subtracting 10/15 minus 12/15, but you can't do 10 minus 12. Okay, so we're going to have to borrow from the whole. So 5 and 10/15. Let's rewrite it with an improper fraction. I'm going to replace the 5 with 4 and 15/15. Means the same thing. 15/15 is equivalent to 1 whole. So now I'm going to rewrite it. Is 4 and 25/15. And now I can subtract 25/15 minus 12/15, and I get 4 minus 2 is 2. 2 and 13/15. 13/15 is in simplest form because 13 and 15 don't share a common factor. All right, let's start with Raymond. They're asking us to write an equation here. Okay, so it says Raymond has 3 times as many trading cards as his friend David. Okay, so here would be Raymond. And here's David. Notice how I drew Raymond's box longer because he has 3 times as much as David. So, if David has D amount, then Raymond has D amount plus the same thing again, plus the same thing again. 3 times what David has. Okay, now they tell us how much David has. David has 34 trading cards. Write an equation that could be used to find R, which represents the number of trading cards that Raymond has. Okay, well, take a look at the picture that we just drew. If the amount that David has is 34, then each of these parts is equivalent to 34. 34 times 3 equals how much Raymond has. Mrs. Campano. Okay. She has 3 cases of pencils. Each case contains 96 pencils. Okay. 3 cases. Each case is the same amount. Says, what was the total number of pencils purchased? Write an equation that shows this problem. Okay, so the total would be 96 times 3. 96 times 3 equals P, total number of pencils. Okay, Bill. Okay, so Bill wants to give away 1,152 trading cards. That's very nice. He divides them equally among his 8 friends. Okay, so he's got 1,152 cards, and he's dividing them equally among his 8 friends. They all get an equal amount, T. He writes the equation 1,152 divided by x. Oh. I would assume equals 8. The x has to represent, so we're going to replace our t because they picked x instead. The x has to represent the number of trading cards that each person gets. Because if he were to divide it equally 8 times by his 8 friends, this problem, this x, would indicate how much each person gets. So the x is how much each person gets. Okay, for Thursday, write the fractions and decimals in order from least to greatest. Start with the first one. Okay, 2 1/4, 1 75 hundredths, 2 1/8, 1 2/3, 60 hundredths, and 1/10. Okay, let's start with the 2 that are less than 1. These ones right here, 60 hundredths and 1/10. They're both decimals, so we can write them on top of each other to help compare them. I can add a 0 because 10 hundredths is the same as 1/10. When you look at the tenths place, 6 tenths is greater than 1/10. So that means that 1/10 is the least. 60 hundredths comes next. By the way, the problem says in order from least to greatest. You always want to check that because sometimes they do it from greatest to least. Okay, so then I've got 2 values that are 1 whole, greater than 1 whole but less than 2. 1 2/3 and 1 75 hundredths. Okay. So 1 2/3 weak and 1 75 hundredths. if we were to take 1 and 75 hundredths and write it as a fraction, we can simplify this fraction to see if we can determine how it compares to 1 and 2/3. 75 and 100 share a common factor of 25. One and 3/4. So 1 and 75 hundredths is the same as 1 and 3/4. So now we need to compare 1 and 3/4 and 1 and 2/3. Remember in a previous Math Minute, we talked about some ways that you could kind of conceptualize fractions. Because now we need to compare 3/4 and 2/3. So, what you can think about is the fact that the numerator is 1 less than the denominator. So, because fourths are smaller than thirds, this is 1/4 away from the whole. And this is 1/3 away from the whole. That's going to make this number 3/4 greater. Let me show you what I mean. So here's 2/3. It's 1/3 away from the whole. And here's 3/4. That's only 1/4 away from the whole. Fourths are smaller than thirds. And you know what? My drawing isn't actually very good. Nope. Okay, that helps you see it a little bit better. Since fourths are smaller, you're doing 1/4 away from the whole. That makes this number, 3/4, a greater fraction. Okay, that was kind of a complicated way to explain it. There's a lot of different ways to think about fractions and how they compare to their decimal equivalences. So 1 and 2/3 comes next, and 1 and 75 hundredths comes after that. Okay, so now we have 2 and 1/4 and 2 and 1/8. Okay, so because they're both unit fractions, we can think about what's smaller, eighths or fourths. Because the whole is divided into more pieces, 2 and 1/8, eighths would be smaller than fourths. Okay. Now I did not model this here. Oops, but you can always divide them out. You could divide 2 divided by 3 to find the decimal equivalence of 2/3. All right, so now let's look at 2. They're all unit fractions, which is awesome. It makes it so easy to compare. Unit fractions means that there's a 1 in the numerator. Okay, so for unit fractions, the greater the denominator, the smaller the fraction. And I'll show you with 1/2. And 1/8. 1/2, you're dividing the whole into 2 equal parts. That makes each piece pretty big. Now 1/8, you're dividing the whole into 8 equal parts. That makes each part pretty small. the more you divide it, the smaller the pieces will be. Okay, think about it. Would you rather have half of a pizza or 1/8 of a pizza? Well, if you're hungry, you want the bigger piece, 1/2 of it. Okay, I think they asked us to order these from least to greatest. That's going to make 1/9 the least, followed by 1/8. Followed by 1/6, 1/4, and 1/2. And here, we're almost done now. Write the decimal for each set of words. Okay. So you kind of just need to read this out loud. 123 and 7/100ths. Okay, so when you see that and, that indicates a decimal point. So 123 and 17/100ths. Just as a quick review, okay, after the decimal, we've got the tenths place. Let's just come up with a random number. This is the tenths place. This is the hundredths. This is the thousandths. And this is the 10,000ths. What they mean is how much you're dividing up the whole. Okay, so you can divide the whole up into 10 equal pieces, tenths, 100 equal pieces, hundredths, 1,000 equal pieces, thousandths, 10,000 equal pieces, 10,000ths, and so on. That's what that means. So for 17/100ths, you look at the last digit in 17, and where is that located? It's in the hundredths place. Okay. 6 and 5/10ths. So 6 and the decimal point, 5/10ths. So that 5 needs to go in the tenths place. 762 and 762, and there's our decimal point. 289 thousandths. So that 289, that last digit needs to be in the thousandths place. And it is. 546. And there's our decimal point. 92 hundredths. Okay, that last digit 2 has to be in the hundredths place. And it is. And we're good. We're finished. Nice work.